Hello and good day in geometry. We are starting proofs in CO15, and our focus is going to start with the algebraic proof. So we're going back to something that we've done frequently, even this year, and that is opposite operations. When we used opposite operations to solve for a variable in algebra, you weren't asked to defend the steps. We just said that we're keeping the equation balanced, right? It turns out there are actually what are called algebraic properties of equality that validate, or why they're called proofs, prove that using opposite operation works. Okay, I use the analogy of the science balance scale. You know, why do we subtract 5 from both sides? Well, it keeps the equation balanced. That's good enough for algebra, but if you're actually going to prove and defend it geometrically, then we have to use these properties here. So these properties are things that you are going to be using going forward. They're all key points. They should end up on a help sheet, and they are going to be, very helpful. Okay. You'll recognize the form that we're going to use too. Back to CO12, we'll be using conditional statements, if-then statements here. So the addition property. If A equals B, then A plus C equals B plus C. Shocking news, I know, right? If A equals B, then A plus C equals B plus C. Basically saying that if you add the same thing to both sides of an equation, the value doesn't change, right? The subtraction property says that if A equals B, then A minus C is equal to B minus C. You can subtract something from both sides, and it's okay. It's a mathematical property. Okay. The multiplication property, you can probably guess, if A equals B, then what? AC equals BC. You can multiply two sides of an equation by the same thing, and the value will remain the same. Or they'll be equal. I shouldn't say the value is the same, but the two sides will remain equal. Yes, Luke? Well, this next one, the division property, there's a second caveat here. If A equals B and C is unequal to 0, then A divided by C equals B divided by C. Why do we have to add in that little extra piece about C being unequal to 0?
Because anything times 0 would be 0. Anything divided by 0 would be itself.
Anything divided by 0 is mathematically illegal to do. You ever get that divide by 0 error in your calculator? Okay, you cannot divide something by 0. Have you ever asked Siri to divide something by 0? It's like a Cookie Monster answer, something like that. But the reason why you can't divide by 0 is, remember what division is, right? It's, for example, 8 objects divided into 4 groups. There will be 2 objects per group, right? You can't have 8 things and divide them into 0 groups. I mean, if you have 8 things, you have at least one group, right? You can't divide them into nothing because you have something, right? So dividing by 0 does not mathematically make any sense. And so you cannot do it. Yes, Luke?
Would there be anything for multiplying by a 0? Would there, because everything multiplied by 0 would be 0.
Right.
So would there be the times 0 property?
No, because remember what multiplication is? It's repeated addition, right? 8 times 2, for example, means you're adding 8 twice. 8 times 1, you have, 1 8, and 8 times 0 means there isn't anything there. Okay. The substitution property. I should have 2 lines for this, so write kind of small here. But if A equals B, then A can be substituted. It'd be helpful if I spelt it right. Substituted for B in any expression. If A equals B, then A can be substituted for B in any expression. I want you to star this one because we won't use it quite as much in CO15, but going forward, that property is going to be one of your go-to things. Okay? The substitution property, it's not prevalent in CO15, but going forward, you'll be using it often. Right? Then finally, the distributor property, we've talked about this in algebra as well. If A times B plus C, I shouldn't say that. This one actually isn't an if-then statement. But the property of A times B plus C is equal to AB plus AC. Okay? Just distribute that A in and multiply it by each term within the parentheses. So what you're doing when you solve an equation, the mathematical properties behind it are these mainly four up here: addition, subtraction, multiplication, and division, and a little bit of the distributive property too, right? So to make a proof, anyone still need the notes here?
Yes, I do.
Okay. Yes, question?
So that tricky tutoring objective thing we did,
Yeah.
that's gonna be on the test.
Yes, not a logic puzzle like that, but it's going to be, if you know this, can you conclude this type of stuff?
So like a dumbed down version.
A dumbed down version, yes, you can think of it like that. You'll see what the format is on the practice test, and then it'll be similar on the actual test. Which, by the way, PO16 is our last objective of the unit. So plan on a test next week, the second session. So either Thursday or Friday. So next week, Thursday, or next week, Friday. Okay. All right. Getting down to seeing this in action here. It says solve each equation, write a reason for each step, use the backside if you need more space. Given the amount of space that I left you, and I'm offering you to, if you need more space, use the backside. You can kind of see what type of process this is going to be. So for starters, I want you to do this. Make a T-chart, okay? And the left column is the statement, and the right column is the reason. Okay? You can think about this as a hypothesis and a conclusion type of thing. Right? So your statement, every single proof will start out with a given statement. And in this case, our given statement is the equation. What do we know? We know that 4 plus 8x equals 10x minus 10. Okay? 4 plus 8x equals 10x minus 10, and we know that because it's given. Now, algebraically, what would you do first to solve this equation? Linnea? Sorry? What like terms could we combine here? And by combined like terms, we still need to use opposite operations here, right? We couldn't say that that is 18x, which is what combined like terms would kind of lead to, because they're on opposite sides of the equal sign. Okay? What would we have to do to move all their x's to one side? McKenna? Okay, if we subtract 8x from both sides, the nice part about proofs is you don't really have to show your work, okay? But the caveat is you have to explain why you did it. So our second step, we could write 4 equals 2x minus 10. Subtract that 8x from both sides. So in red, I'll write what we did, even though it's not going to be a necessary part of the proof, because you don't have to show the work, you just have to explain why. And the reason why we did it is because of the subtraction property. The subtraction property tells us that we can subtract the same thing from both sides. That minus 8x is us subtracting the same thing from both sides, and it's okay, right? The value of each side of the equation is not going to change. The numbers do, but the value doesn't. Luke?
Yeah, so for the reasons, are we just only going to be putting like subtraction property, division property? Oh.
Yes.
Okay.
The reasons can only be definitions, properties, postulates, theorems. Okay? These are not a place for opinions or conjectures, right? This is a very deductive reasoning proof. This is a proven fact. The subtraction property, is a fact that we can use it. Yeah. Sure. If you want to call it the subprop, that's okay. And actually, it's the last part. This is even abbreviated from subtraction property of equality is the full property. So the subprop of Eck, that would work too, but the subprop, that'd be fine. Okay. What would we do next here? What would our next step be in solving this equation? 4 equals 2x plus 10. Christopher?
Plus 10.
Adding 10 to both sides. So I'll write that in red. You don't need to include it as part of the proof because it's not necessary, but that's what's happening here. So our third statement would be 14 equals 2x. And how can we defend that step? How can we defend that step? Nick? The addition property of equality. Yeah. Or the add prop. Okay. And how about next? What would our next step be to solve this equation? Bonus points if you can give me the reason why. Linnea? Divide both sides by 2. Again, you don't have to write the red part there. Your result would just be 7 equals x. And the reason why? The division property of equality. Okay? So there you go. You've just written your first formal proof. Congratulations. Okay? But it's the logical from start to finish, the mathematical reasons why. Right? You can do this. Yes. Next one. Again, make that T-chart. We have the statement and we have the reason. Okay. What's our first statement and reason here? What's the first reason, Nick? Given. You always start with what's given. Okay? And in an equation, solving an equation, what's given is the equation itself. 7 minus 12 times n minus 4 equals negative 18n plus 37. I never leave myself enough room for that. Okay? But your first statement is what's given, in this case, the equation. Luke?
Could you say given reason to that?
Does it matter?
Well, no, that's just what I put.
What do you mean given reason?
So for number 1, can I put like given reason?
Like you wrote the word reason after given?
Exactly.
Oh, given statement would be better than given reason. What would you do first here? What would your first step be to solve this equation? Noah? Distribute the negative 12. Again, you don't have to write this as far as the work, but that's what's happening here. So your second statement is going to be 7 minus 12n plus 48 equals negative 18n plus 37. And what is our reason for being able to do that? Distributive property. Okay. Next, if this were an equation, what would our next step look like? You got some options here. You know, the nice part about this is that you don't necessarily have to do this in a set order, just so long as you get down to the variable by itself and be able to defend each step. So who'd like to take the reins here and kind of walk us through where they want this proof to go? What would you do next? Christopher?
Add 18 to both sides.
Move your 18 ends over.
Yeah.
Okay, so doing that would give you 7 minus 12n. Oops, no, it wouldn't. It'd be 7 plus 6n plus 48 equals 37. And the math behind that is adding 18n to both sides. Okay. And why are we able to do that? Christopher?
Because both sides of the equation are equal.
I need the geometric property.
Sorry, it's addition property.
Addition property, yeah. Okay. Where to next? Picking up from where Christopher left off. Step 4, McKenna.
Combining 7 and 48.
Okay. So step 4. Oh, I should have written that in red. Okay. So we get 6n plus 55 equals 37. Our reason for this would not be the addition property because we didn't move anything over from one side to the other. This would be an example of a definition. What did you do? Turns out combining like terms is actually a definition that can be used in a formal proof. Okay. It's not really a property, but it is a definition. So our step 4 is that we combine like terms. Now what? And really steps 3 and 4 are the two that could have been interchanged, right? We combine like and then move our ends over. We decided to move our ends like those could be interchanged, but from step 2 is pretty standard. It has to be done next. And then steps 5 and 6 here also. I'll forgive you. Subtract 55 from 37, and we get negative 18. There's the math behind it. And we're able to do that because subtraction property. Okay. And last but not least, one-step equations. So one step left to do. Thumper. Divide both sides by 6. So step 6, we have n equals negative 3 because of the division property. Okay. So on your test, you will have 2 equations to solve, just like we had here. Okay. For each of them, each is worth 2 points. 1 point is that you solved the equation correctly, because that's still important. Okay. And the other point is that you had the correct steps and reasons and things like that. Right. So that's kind of how this is going to be graded for this objective on the test. 1 point for the correct value for the variable, and the other point that you listed all the properties correctly. And you had a formal proof set up, right? This T-chart, statement, reason, okay, down the line there. Christopher?
I go into another room to get my pencil sharpened, like Miss Chalmers.
Yeah, I don't have a pencil sharpener anyway. I don't think. So yes, go ahead. I don't know. Yeah.
So when would we use the substitution?
So the substitution property, like I said, it doesn't really show up in 15. But if you were asked to check, then you could say that because n equals negative 3, you could rewrite the equation with negative 3 in for n because of the substitution property. But where you'll see it more is when we get to geometric proofs in PO16, substituting different congruent angles, congruent segments, things like that. So you will become very familiar with that property, just not so much in the algebraic sense. Anything else? Any questions on?
No. Oh,
Okay. Any questions on what we did here? Kylie? We are not doing PO16 today. I don't want to overload you with so much fun all in one class period. Okay? Hold on, don't pack up yet, folks. I still have to assign the homework. I want you to hear it so we don't have any confusion. Christopher?
So is the test gonna be online or?
The test will not be online. I don't love online tests. Just the timing of the last one kind of forced my hand there. But this one will be an in-class paper and pencil test. Okay, especially with writing proofs, online would be very challenging. Kate.
So are we not going back to CO13 at all? Are we just done with it?
Your homework today kind of goes back to CO13 a little bit. I'm going to give you another logic type question, but we're not going back to it. Did you have a question on it, or
No, we didn't really finish like this. So
the tricky touring?
yeah.
We went over it.
So on here, like
Oh, CO14, the postulates and stuff.
no, it's CO13.
Oh, the difference between deductive and inductive reasoning. We talked about it. I don't know if I actually wrote anything up on the board. We kind of did. Deductive reasoning deals with facts and logic and is well thought out. Inductive reasoning is very, very quick. It's judgmental. It's observations and experiences. Okay, Linnea. You may use a calculator on this test, yes. I don't know how much it'll help you other than just checking your work, but yes, you may use a calculator. So your homework for, what day is today? For Thursday, on page 101, this kind of goes back to some logic stuff here, so 13, 14. But number 39, it is multi-step. It's A through E. So don't forget to do all parts. Okay, so just one question on page 101. And then from this stuff, the proof writing, I would like you to do on page 109. And you've got about 20 minutes here to stay and work on it and get it done. 6 through 12 even, so not a lot. Yes, 6 through 12. So 6, 8, 10, 12 is what I'd like you to do. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Okay, that's high math.